Hear you.
Yeah, hello. So today is we have solved with a session for week 5, and we'll be doing some questions from there. Just give me 1 minute and then we can start. Yeah, so we're doing questions today from week 5, and this is the first question. I'd like you guys to give this a
Can't hear
try.
you.
Okay, can you hear me now? Am I like not audible at all, or is my voice breaking?
It
No,
is
audible now.
audible, ma'am. It is clear.
So give this question a try, and then we'll do it here. It's a very easy question though. Let's just do it here. You can try the other question. So this question is, it says that a 2p is equals to q and you have to find the value of this expression. So the expression is 4p by 2q, 2 to the power q, plus 25 to the power q, and 625 to the power p. And your q has been given to be equal to 2p. So you can replace q with the 2p, and then you can replace this. So this
Ma'am, your voice is low actually.
is it better now?
Yes, ma'am. It is better.
Okay. So you have a 25 and then it's raised to the power q. Q is 2p and this is 625 to the power p. So now we have all the powers in p, and this you can express as 2 to the power 2, right? So 4 is nothing but 2 to the power 2 and raised to the power p. So this becomes 2 to the power p. That's the rule for uh, indices, right? That if you have this thing, then you can just multiply p with 2. So you get this thing and this thing plus 25 to the power 2p, and 625 is nothing but 25 squared. So you have 25 raised to the power 2, and then you have p. So this thing. And then this is nothing but 1, and this expression is also just 1. This gives you 2. A very easy question. Uh, I hope this is clear to everyone. So can we move to this one? Give this one a try. You can drop the answers in the chat box once you're done. Is anyone done doing this question?
R.
Okay, let's see if it's our. So x to the power you have to find the domain of composition of two functions, which is GOF, right? The domain in general of composition functions is this. Domain of the first function, f, this one. the one that's applied first. When you do G O F, you apply F first, right? This gets applied first on X, and then G gets applied on Fx. So the first function F, and then intersection with all the elements, this is a set. We are taking elements from R because we generally take the domain, or I should call it the domain, or just R. R is fine too, because we are only dealing with real valued functions. So X such that your F of X, this thing, you have G O F X. That means you have G, and in the argument of, this is the argument of G. Argument means this thing. Uh, if you have Fx, then X is called the argument of F. So basically what the function is being applied to is called the argument, right? So the argument here is Fx, and you need to make sure that your Fx is in the domain of G, right? Only then you can apply G to it. That means you have to make sure that Fx is in the domain of G. So it's basically the collection of the domain of the elements in the domain of F, and then you also, so this is the first condition, it should be in the domain of F, the first function, and the second one is second condition. These two conditions should be satisfied simultaneously. That's what intersection is. The condition is that your Fx should be, if X, using X here in the argument of GOF, then Fx should be in the domain of G. Only then you can apply G to Fx. So this is the domain of the composition function, right? Now let's find the domain of F first. Your function is square root of X plus 1. Okay. Just to make things clear, although I know you guys know this already, but when we talk about square root of something or square root of X in general, so this thing is just X. So if you have root 2, this just root 4, this just means 2. It does not mean minus 2. And if you have to get minus 2, that's another function, which is this. So if you will apply this, this is a function, right? This is a function. If you will put 4 here in place of X, you will get just 2. And if you want to do the other part of it, then it should be this thing. You should write it as this, minus of mod X, minus of root X. Now if you do minus root 4, you will get minus 2. So if you have square root of X plus 1, the only thing that you can get is, though it's not relevant to the question, but the range is only going to be positive numbers. It can't be a negative number. Okay, now coming to the domain of this function. So domain has to be this, what's inside, right? What you can put here in place of X. So in place of X, for the domain of F, what you should be doing is, you need to make sure that your X plus 1 should be greater than 0. So if you treat this as a function, this, by the way, this is also a composition function. Square root of X plus 1 is also a composition function of two functions. One is X plus 1 and the other function is square root of X. It's the composition of these two functions. So for this, you need to make sure that the argument is this argument, X plus 1. What's inside the square root should be greater than equals to 0, right? This means your X should be greater than equals to 1.
Minus 1,
Because you
it
can't
should be.
find, yeah, minus 1, because you can't find the square root of negative numbers. So you need the argument. Argument basically is this thing here. The square, if you treat this as a square root function, then this entire thing is the argument of square root function. This entire thing, X plus 1, should be greater than or equals to 0. Negative square root of negative, because the square root of negative numbers is not possible, or at least not defined when you are talking about real value functions. So your X should be greater than equals to minus 1. Now this means your X should belong to minus 1 to infinity, right? Minus 1 is included here because you can take this equal. So this is minus 1 to infinity. Then coming to the second part, which is this set. It's belonging to R such that your functions Fx should be in the domain of G. Let's just first find the domain of G. G function is
But in this, if we put -1, then the function is not defined like we agree.
Why, if you'll put -1 here, you'll get 0. Square root of 0 is 0. Do we have a confusion in why -1 is also a valid choice for x here, and why it should be in the domain of f? The, the domain of g is this function x square minus 1. Now x square is, whenever we talk about a domain of a function, we basically mean all the values that we can substitute in place of x. So everything that you can put in place of x and the expression would make sense. Like if I put -1 in place of x, I'll get -1 squared minus 1. Now this expression makes sense, right? You can find all the values there. This is, everything is defined here. -1 square is 1, then -1 is, you'll get 0 here. But if you have something like, let's say you have square root of, or square root of fourth root, let's just take square root. So if you have square root of minus x, now if I'll put x equals to -1 here, then it's fine, right? I can substitute x equals to -1. So I'll get, this expression would become square root of 1, right? So this makes sense. That means this is a valid input. But if you put x equals to 1 here, you will get square root of -1. And this is not a well-defined real number, right? Square root of -1 is not a real number, and we're discussing real valued functions. That's why this is not a valid input. Or you can't substitute x equals to 1 here in square root of -x. What can we not substitute here in x square minus 1? Is there anything that we put in place of x and the expression won't make sense?
No, no, no.
We can,
X, X
It will
belongs to R.
depend on all real line.
the someone's on unmute. Can you mute yourself? Okay. So this is it. And then the domain of G, because you can substitute, if you will put 1, you can put here, you can put positive numbers here, negative numbers here in place of x. So everything works here. For every number, the expression makes sense. Every real number, this expression makes sense. It's a valid number that you will get, real number. That's why the domain of this should be R. So the domain of real, for G function is R. Domain of F function is this, -1 to and this, for this expression, this one, for this, now because we're lucky here, our domain of these real numbers, we don't really have to check it. Because if your function is from a set D to R, right, we have to find the collection of x such that fx is in R. That means you have to find every possible value of x such that your fx will be in the set R, real numbers. Now, no matter, because your codomain is real numbers, that means no matter what value you substitute in this function, you will always get a real number, right? Because your domain is real numbers. That's why this set is just going to be equal to, what is this set going to be equal to? This one, the other second, the one that I marked, is in the domain of G. That's also fine. So this will just be the set of real numbers, right? Or you can say the domain of F. In this case, because you change the set, this will just be the domain of F. your domain of f is this -1 to infinity. That means you have to take now this entire thing. This is second expression, this 2. The domain of f is this -1 to infinity. That means their intersection is going to be equal to domain of GOF. This is equals to -1 to infinity intersected with the set -1 to infinity. So this means what do we get when we take the intersection of same sets? That same set, right? -1 to infinity. So you'll get this thing. So the correct option should be this one. Is this clear to everyone? Does
Yes,
anyone have a
ma'am.
doubt in this particular question?
Ma'am, can you show the question?
Yeah.
Ma'am, this GOF is X, right?
Okay. GOF. One second. A g function was square root of x plus 1 and your g is this. So this becomes square root of x plus 1 squared minus 1. But when you write, see, when you have a function, it means obviously there are two things in a function. One is the domain of the function. If you have this b to r and you have square root of x, let's say you have x squared. This is one function, and then this is another function where you have b to r, b dash to r. I've changed the domain and I've kept the expression same. So if you change the domain, the functions become different. Now this function and this function are two different functions. They're not same, right? So if you have this thing here, why we're discussing it here? Because you have this thing. If you look at now it looks like x plus 1 square root squared, so I'll get x plus 1 and then minus 1, so I'll get x here. It looks like it's the function is fx equals to x, right? It looks like it's the function fx equals to x, but it's important to note that it's this function is not the same as the function every real number. That's a different function. Is that okay?
Your voice
So
is
it is
breaking a
x
lot.
in
You
expression.
can fix your mic.
Okay. So the expression for the function, this function as expression is same. Expression in the sense this thing is same as the identity function, but this is not the identity function, or at least it's restricted. The domain is restricted.
Yes,
Is that
ma'am.
okay?
Yes, ma'am.
The
Ma'am, what
domain
I
also changes the function. Yeah.
okay. What I wanted to ask was, I have verified that GOF is equal to FOG, which is equal to identity function, right? Then if we are asked to find the range of any function, let's say we are asked to find the range of f of x, can we say that the domain of g of x will be equal to the range of f of x?
So you
So
have your
we have
fx is,
verified, yeah.
but it's only they're inverses of each other only on this domain. So you have -1 to infinity, right? Only on this thing are they are inverses of each other. Now outside this, they're not inverses of each other, right?
Okay, okay,
So you'll have to be careful of that.
okay, ma'am, okay.
Fx is only the inverse of what's the function x square minus 1. Fx is the inverse of this thing, is the inverse of this only on this thing. Now outside this isn't even defined, right? So it's not the inverse there. And in fact, okay, uh, if you have x square, so if you'll find the inverse of this does not exist, right? Does not exist in the sense if you're taking the usual domain for this, if you have,
Yes, ma'am. If we restrict our domain
yeah,
to 0 to infinity, then inverse would be x to the power half.
Or if you have this thing x square, whenever x belongs to R. Now the inverse does not exist. But if you will take fx equals to x square, or x belonging to, you can include 0 here, 0 to infinity, or you can take fx equals to x square, where x belongs to 0 to 0 to minus infinity, right? So if you will take these, now these two functions are different. This is a different function, this is a different function, although they look the same, because the expression is same here. They are different functions. And if you will find the inverse of this, now the inverse of this function is square root of x, and the inverse of this one is minus square root of x. We'll discuss that in more detail later. When I think we have a question on this too. So we'll discuss this thing there.
Okay, ma'am.
But in general, your question was, what was it?
Ma'am, like I am,
Yeah, the range and domain thing. If you can say
yes,
if this
ma'am.
is the domain, so if you're asked that what's the range of this thing, now
Yes, ma'am.
obviously the range is, this is positive real numbers, and if you let's come to this one. If you say what's the range of this is also, so you can't actually. I'd suggest not to go by that rule here, unless you know that this is the. If you are very sure that this is the function, this is the inverse on this given domain, and so domain also is restricted, right?
Yes, ma'am.
Now, if you
Restricted.
see, yeah,
Okay.
but in this particular one, it does make sense. The domain of this is the domain, and the range of this is indeed 0 to infinity. So it does make sense that the domain of one is the same as the range of the inverse of this one. In fact, here also it makes sense, and in this case too, it makes sense. Right?
Okay, ma'am.
So
Then it
again,
would
here
be
is,
1 1 as well as on 2, right?
yeah. If this one, both of these functions taken separately, this one and this one, they are both 1 1 and on. This is 1 1 and on 2, and this
Okay,
one is
ma'am.
also 1 1 and on 2, separate functions. Let's come to this one. Give this question a try. Okay,
Is it
let's
option
do
B?
this here. Okay, let's see if it's B. So you have one function f from -1 comma 2. This is the domain, and the other thing that's given is range as well as codomain. So the codomain and range are equal here. The We don't need the codomain, so leave it. This is the range. And then we're defining another function g, where we're defining g of x is equals to 1 minus f of x plus 1. We have to find the domain and range of this function of g, this one. So let's come to the domain first. The domain is what you can substitute in place of, one second. Domain of g is basically what you can substitute here, right? That means what you can substitute here, just here. What values can you put here in place of x? For domain of g, because we know that f for the domain of f, where x should be in between the -1 to 2. So where x should be in between -1 and 2. Now, the argument of f is this, right? That means what this means is everything that you will put here, f bracket here. Now, if I write it y, I write it z or anything, it doesn't matter. Everything that I put in this bracket, that means that should be in the domain of f, right? Then only I can put it here in the place of argument of f. That means if I'm putting x plus 1 here, so x plus 1 should be in -1 to 2, right? This x plus 1. That means your x plus 1 should be less than equals to 2 and greater than equals to -1. And I have to find the domain of g, which is just x, right? You have to find what values can x take. And you have the value that x plus 1 can take, right? Because x plus 1 is in the domain of f, so it can take the values from -1 to 2. Because this entire thing is the argument of f. So x plus 1 has to be between -1 and 2. Whereas you have to find the domain of g. That means you have to check what can you put in place of x. So if you can put x, if x plus 1 can lie between -1 and 2, then
X should be greater than equal to
lie
-2.
between -1, -1. Right. This will be it. This is -2, greater than
-2
equals to
and 1.
-2, and this will be less than equals to 1. That means your x should lie between, if you write it as interval, this will give you x belonging
Ma'am,
to
your voice is breaking.
Voice is
-2 and 1 closed
breaking
interval.
frequently, ma'am. If you can fix that first.
I am not sure what's going wrong, and I'm trying to keep the mic close to myself. Is it still breaking or is
No, ma'am, it is clear now. Sometimes
okay?
in between it is breaking.
It's clear now, but
Yes, ma'am.
when you are explaining in the flow, it breaks frequently.
Okay.
Yes, ma'am.
Try to avoid that then. And then next you have to find the range of this function gx. So range means what you are 1 minus what you are going to get. So what this expression lies between, right? This is what you have to look for. So we know that fx lies between. This is this thing. If this confuses you, you can just replace it x plus 1 entire thing with a y. And you can call this fy, 1 minus fy. So we know that your fy, fx, because this is just a variable. You can write it fy, fz, fx, whatever you want, right? So this lies between, the range is 0 to 1. That means it can take values 0 and 1, and it lies between 0 and 1. And you have to find 1 minus fy, right? So that means if you do it bit by bit, then it will be, if your fy is in between 0 and 1, that means your minus of fy, the entire thing gets multiplied with minus, and when you multiply an inequality with a negative sign, it gets changed, That means if you have fy less than equals to 1, if you multiply with a negative side or sign on both sides, minus fy will be greater than equals to minus 1. Now if you'll do it here, so first let's just consider this one. If you multiply negative on both sides, you'll have minus fy less than equals to minus 0, which is just 0. And if you do it here on this one, you will have minus fy. This inequality gets changed. So minus fy will be greater than minus 1, right? So this is it. So basically this entire inequality gets flipped. Minus 1 when you multiply with minus 1. Minus 1 comes here, minus fy next, and then 0 in this ascending order. And then you add, because we have 1 minus fy, so you'll have to add 1 on both sides. You have to find these values, right? What does 1 minus fy lie between? You have to find these two. So you'll add 1 on each part of the inequality. So this will be 1 minus 1, 1 minus fy, and this will be 0 minus 1. So this is going to give you 0, 1 minus fy is greater than 0, and less than minus 1. That
That
means your
should
range
be
is,
+1, ma'am, in the right hand side of the inequality.
yeah, yeah, thanks. So we have 1 here because it's 1 is added here, minus is all. We've already subtracted 1, fy. So this is going to be plus 1 here. We've added 1 here, 1 on this side. This will mean, 1 second. We have minus 1 already. So I have to add 1 here.
Plus 1.
This will give you plus 1. Minus fy already add 1 and 0 already. So we'll have to add 1 here. So this is going to give you 0, 1 minus fy, and then 1. So that means your 1 minus fy is going to be in the interval 0 to 1. That's your range. This is for range and this is for domain. So that means this option, B1. If this one is clear to everyone, can we move to the next question?
Yes, ma'am.
Does anyone have a doubt in this particular question?
I didn't took this long approach. I actually took, like, since the domain is from -1 to 2, so I shift the limit, like upper limit and the lower limit from 1, and the range, keeping it as it is, like it would be in the same range. So do we have to go by this long approach, like how we approached it?
No, no, you just have to get the answer. This, whatever you're saying that you're shifting things from there, that also comes from here, right? Why you're actually shifting, what you'll be doing is because you've added 1 here in the domain, that means you'll have to subtract things from here. You shift it to the left,
Hmm.
right? So,
Right.
which actually makes sense because that's what we do in functions. So if your y is equals to fx, or if you have y is equals to fx minus a, then you shift it a units to the left, right?
Correct.
Actually, this one is shifted to the left, so and minus is shifted to the right. That's fine, but this is where it comes from, right? You don't
Okay.
have to go by the long approach. This is
Okay.
just the explanation of why we do this, why we shift everything to the left or right.
Okay.
But
Let's come to this one. Yeah,
hello,
yes.
but he said the range is remains same, but this method is right or not?
The range, that's also going to change. See, when you do this
Yeah,
thing, okay, let's say you have this thing, y is equals to 1 minus fx. Now, I think I've already discussed this method somewhere in when we were doing polynomials and all, but I'll do it.
yeah, but he said that the range became same in every situation. So I said,
The range won't be okay. Let's do it here for everyone who already knows it and who doesn't know it already. We can do it still. If you have y is equals to fx, and if you do y minus a and x minus b, y minus y naught, then this simply means that your graph gets shifted. Now, if let's say if this was this graph, if this y is equals to fx is this graph, then this graph gets shifted y naught unit upwards because y naught is subtracted from y, and x naught units to the right. So this point on this graph will get shifted. This units, x naught units here and y naught units here. That means somewhere here. So it gets shifted here. Similarly, other points get shifted in the same manner. So that's exactly what we're doing here, right? In this range 2, what we're doing is, if you'll consider this entire thing as y plus 1 or minus 1 and minus of fx plus 1. This just simply means that you're shifting, and this negative sign means when you have fx and you take minus of something, let's say you have y is equals to fx. And if you do y is equals to minus fx, that means your x coordinates on the graph stay same. Y coordinates, if you have this thing, and that means your y becomes negative. That means every point, if you have some point here, then it has an x coordinate here, a y coordinate here. So y coordinate becomes negative. This is positive side, this is negative side. And the x coordinate remains same. So this point gets shifted here. Similarly, this entire graph looks like this. So if this is fx graph, this is minus fx graph, right? And if you had a first thing is the entire thing gets shifted, and then the negative sign is also there. So initially your range was, what was it, 0 to 1, and then you shift it actually by 1 unit. So you have 1 plus 1 here, minus subtracted from here. That means it's shifted to the right. Right? So this becomes, it should have been minus 1 and then 0, but then you have a negative sign here, right? And we know, we just discussed it here, that if you have y is equals to fx, and if you do y is equals to minus fx. So if your range was this, initially your range was this, right? This is the range, everything above this point. If your function is this, just 1 second. If this is your function, then the range is this for fx, right? Everything above this point. This is the range for fx. But now if you do it for minus fx, it will become this thing. Your graph becomes this for minus fx, and your range becomes this. So the range, what it means is, this is the same range, only the sign has changed. That's, here it was, let's say, from a to infinity. Now it becomes from minus a to minus infinity. That has changed. So if your range here was minus 1 to 0, that means it should change now, and it should be from 0 to 1. Is that okay?
Yes, ma'am.
This is the graphic. This was the graphical interpretation. Otherwise, you can do it by this method. That's fine. That's, I wanted to show how it changes graphically. What does it mean when you put a negative sign, when you add things here in the domain, or you add things in the range? That's it.
Can you go to the method that you were doing so that I can take a screenshot of it?
Which one? This one?
Yeah. That one. Wait a second. If you, yeah. Okay.
Is it done?
Yeah.
Okay. So give this one a try. This is the next question. Just 1 second. Yeah.
Ma'am, it should be 0011.
Okay. Let's try this one here. We have fx equals to x squared, as function, and its domain is restricted from 0 to infinity. And basically, when you restrict domain, it's in, at least in this week, it's generally for inverses. You're restricting it because otherwise you can't find the inverse. And choose the point where the graph of the function fx and f inverse of x intersect. So why it's restricted, first point is why it's restricted to 0 to infinity is because otherwise you can't find the inverse of this function. This function is not 1 1, that means it's not bijective, that means it's not invertible on the entire real numbers, real line, but it's invertible here, 0 to infinity, or it looks like this on the entire real line, which is a problem. That's why you can't find the inverse. But if you take only this branch is x square for the this is this. So if you plot this function, it looks like this. And when you have a function and you have to find graphically what the inverse means is, if this is your fx, then graphically your f inverse x looks like this. It's inverted about y is equals to x. This is the line y is equals to x, and it's inverted about this line. This will be your f inverse of x. For this branch, the positive, it's called the positive branch of x squared. If you have the negative branch, which is this is also the function fx equals to x squared, but obviously for the negative side, from 0 to minus infinity. Now its inverse is this. This is the line y is equals to x. So it looks like this. You've been asked to find this one for 0 to infinity. This one is for 0 to minus infinity. You have to find the point of intersection. So there are going to be, one is the point x squared, the function x squared, and then the other one is the inverse of this. The inverse of this is basically inverse of this. How do you find the inverse? You put y here, do x squared here for x belonging to 0 to infinity, and then you take, so you have to express x in terms of y. To find inverses, what you do is you find x in terms of y. So this will be x in terms of y is this. And this will be, so your function f inverse of x, this one is a function of y. You can call it fy. This fy is the inverse of x function, fx function. This is f inverse of x. Just replace this with, let's not get into fy and all. And just replace this with x, y with x. So you get the function in terms of x. So f inverse of x is x. Write the function, express x in terms of y, and then replace that y with x. So you get the inverse of the function. And this is for x belonging to 0 to infinity. So your inverse function is square root of x, and you have to find the intersection of this function and this function, right? So it is x square and square root of x. That means you can just square on both sides, x to the power 4 and x cubed. Now what happens is, when you have, I'd like to clarify this thing here while using the square. This is just x, right? That is, if you have x equals to, let's say you have x is equals to 1. Now, if I square it on both sides, I'll get x square is equals to 1. And these two things are not equivalent. This implies this, but this other side does not imply this, basically. So that means every root of this one is also a root of this one, but every root of this is not a root of this. So if you manipulate things here, like you've done here, if you do x square is equals to x and then you square on both sides, then every root of this equation, this one, is also a root of this equation. But every root of this equation is not going to be a root of this one, the previous one.
Okay.
Like we did here, x equals to 1. Now, the only root this equation has is 1, right? But x squared plus 1 has, x squared equals to 1 has 2 roots. I've squared both sides, I've gotten this. Now it has roots 1 and minus 1. 1 is a root of this, but minus 1 here. This one is not a root of this one. This will be, if you take it on this side, you will have x4 minus x equals 0, or you can simply write it as x cube minus 1 equals 0. Now one is x equals to 0, and the other one is, this has 4 roots. If you look at it, it's in complex numbers, at least this is going to have 4 roots, and x equals to 1. Now, you have x equals to 0, x equals to 1, and there are 2 other roots. Let's come to those later. You don't even have to look for those two. Why? Because this is x squared equals to 2x, and the degree here is 2, right? The maximum roots it can actually have is only 2. And those 2 roots are, put 0 here, you'll get 0, 0. They're both equal. Put 1 here, you'll get 1 equals 1. That means 0 and 1 are the 2 required roots. Now you can't have more than 2 roots, so you don't have, that means the other 2 roots that you'll have here will not be the roots of this equation. Because this equation can only have 2 roots, and you've already found 2 roots here. Now, if you still want to find those other roots and check if they won't be real. So if you try to solve this, this will be,
Omega.
this factor is gone, right? So it will be x. If you will expand x cube minus 1, I think it is x minus 1 and then x square plus x plus 1 equals to 0. Then this is an identity, a cube minus b cube identity I've applied here. So one root is x minus this one, this real root. This gives x equals to 0, this gives x equals to 1, and this is a quadratic equation. You can try solving it. You're going to get complex roots. The roots won't be, not complex actually, non-real roots. So you're going to get non-real roots. So there could be there are infinite number of reasons to discard these two roots. One of the reasons could be because they're not real. Other reason that you could see is that this is an equation in degree 2, and you can only have 2 solutions to this, 2 real solutions. And you've already found the 2, so you don't have to look for the other 2 and check if they are real or not. You don't have to go for the extra trouble. But if you still want to just do it for your satisfaction, you can. Is this one clear? We're not done yet, right? So it is x equals to 0 and x equals to 1. And then you have to do nothing. X equals to 0 is given. So the y coordinate will be, if x is equals to 0 and your curve was y is equals to x squared. You will put 0 here, you get 0, 0 point. And if you put 1 here, you will get 1, 1 point, right? So 0, 0 is 1 point and 1, 1 is the other point. That means the 2 required points are this 0, 0, first option and second option. Is this clear to everyone? This is 0, 0, and this point is 1, 1.
Yes, ma'am.
Can we move to the next question if this one's clear?
Yes, ma'am.
This is, if you look at this graph, you can see this is only going to intersect at one place, which is 0, 0. If you had the other branch of x squared, then the function and its inverse would only intersect at one point. This is the next question. Give this one a try. Meanwhile, if anyone has any doubt in the question that we've done so far, let's ask while others are trying this question.
Ma'am, you like your voice is breaking. It's not clear.
Yeah,
Okay, I'm sorry for that. There seems to be an issue on my end today. Is it better now?
Now it is
I'll try to
clear, ma'am.
keep the mic closer.
Should it be E square?
Square, I don't think so.
Smaller point means we should consider the smaller root, right?
So this question, okay, let's do this question here. Question is the value of fx at the smaller point where the graph of the function x square minus fx plus 6 cuts the x-axis. Let's say you have a function fx. Whenever it cuts the x-axis, let's forget what the function is for a moment. This function, don't call it fx, because fx is what gx. This function is gx, this entire thing.
Is it 2?
And it cuts the x-axis at, let's see, if it cuts the x-axis at, you have to find, firstly you have to find where it cuts the x-axis. So where it cuts the x-axis is, how do you find where your graph cuts it? This is y is equals to dx. Then to find where the function cuts the x-axis is, you put y equals to 0, right? So this will be gx equals. So you basically have to find the points x where gx cuts the x-axis is this point, right? All the x for which gx is 0. But do we really need to find the point? It says the smaller point where the graph of this function, let's say this is your smaller point, this is the smallest point where your graph cuts the x-axis. Let's call it a. Okay, so if you substitute a here in g, you get 0. And what do you have to find? You have to find your fx is e to the power gx, right? And you have to find
Yes,
the
ma'am.
value of this at the smaller point where the graph of this function cuts the x-axis. That means you have to find this at a, right? The smaller point is, we're calling it a. That means you have to find fa, and fa is e to the power g at a, and g at a is 0. That means you just have to do e to the power 0.
0.
That's it.
Okay.
It's 1. So basically, you don't even need the function here, but it's still given to you. That's all you have to do in this question. Does anyone want me to repeat this, or is this clear?
It's clear, ma'am.
Repeat this, ma'am.
Or
Ma'am,
Can
okay.
you go down? So here you have basically fx gx. Okay.
ma'am, please repeat this.
Yeah, I'll repeat it. So this question says that there is a function given to you, which is a composition of e to the power x and some other function. That some other function is this square minus fx plus 6. We're calling that function gx. Now it says you have to find the value of this function at the smaller point. So let's say this function gx intersects the x-axis, although we already know that it's only going to cut x-axis at 2 points. How do you find the intersection? Let's first come to how do you find the intersection of a curve with the x-axis? If you have a curve, let's say this is your curve, and you have to find these points. Intersection with x-axis means these points. That means you have to find the curves, the value, this point's value, where your y should be 0, right? Because you're on x-axis, so your y should be 0. That means you should put y equals to 0 here. So you have to find where gx is equals to 0. So basically, you have to find the values of x where gx becomes 0. Gx is this, it's a quadratic function. So one way to do it is you go on and find the values of x where gx becomes 0. And this is a very easy quadratic function. So you can obviously find the values, find the roots, but that's not needed here. So you have gx equals to 0. And this says you have to find the value of this function at the smaller point of intersection. So if this is your gx and it has, although this cannot be the graph of gx, it's a quadratic function. This is just an example. So if this is it, you have to find this function's value at the smallest point where it intersects the x-axis. So if this is that smallest point, let's call it a comma 0, right? So you have to find function's value, f's value at a, at the smallest point, at this point. If this is the smallest point, this intersects here, here, but you have to find f's value at the smallest point a. Now if you'll have, that means you have to find f of a. And what is f? F is e to the power gx, right? This is your f, which is e to the power gx, this function. So you have to find f of a. That's given in the question, right? And f of a is the same as e to the power ga. And ga is just 0. So you don't even have to, it looks like you'll have to find a, but you don't need it. You can do it without finding a. This is e to the power ga. Ga is just 0. That means it's e to the power 0, which is 1. Or if you don't want to use this approach, a simpler, without using any hints approach would be just find the roots here. The roots are going to be, what are the roots of this equation?
3 and 2.
2 and 3.
3 and 2 are going to be the roots of this equation. The smaller root is going to be 2. And then you can
2.
substitute 2 here. So when you will substitute 2
2
in this
0.
one, you're just going to get e to the power 0, which is the same as this one, which is 1.
1.
Is it okay?
Yes, ma'am.
Yes.
And the only thing we need to check is if it is if it has real root or not, right? This
Okay.
quadratic has a real root or not. If it doesn't
Yeah,
have, then
then you won't be asked that, because in complex numbers you can't actually, you won't be asked that.
okay.
In simple words, the question then is incorrect, because there is no comparison in complex numbers. You can't compare numbers there.
Yes, ma'am.
That's why it's an incorrect question. Is this one clear to the one who had a doubt at this question? Can we move to the next question?
Yes, ma'am, please.
If there's still doubt in any of the questions we've discussed so far, we can go through that particular question again. That's fine. Does anyone have a doubt so far? Okay. Give this question a try. Until then, if anyone has a doubt, we can discuss that. Okay. Let's do this here. This question is, it's a quadratic function, right? So you have fx equals x square minus 6x plus 10, which is, because we know it's a quadratic function, it's going to look, and it has positive leading coefficient, that means it's going to look something like this. I don't know if this is a very rough sketch, right? To find the inverse of this function. So for you to be able to find the inverse, you know that for this entire function, the inverse cannot exist. So you'll have to restrict it to a domain where this function is 1, 1. Because this is not a 1, 1 function. And one such domain is obviously if this is the vertex, that means this to this, you have no repetition of function's value. And from this point to this point, there is no repetition. So it's ideal to take this branch. And the vertex is, what's the vertex of this function?
3.
3.
Vertex is minus b by 2a, so it's minus 6 by 2. Minus of minus 6. This is 3. This point is 3. And we're taking it till infinity. That's why the domain is 3 to infinity. So you have to find the inverse of just this one. And as we discussed for y is equals to x square, how do we find the inverse of that? If you have to do it quickly, there's a trick for it, which is if you have y is equals to x squared. So for the positive branch, the inverse is square root of x. And for the negative branch, the inverse is square root of minus x. That means if you have a more complicated function, if you have fx is equals to x squared or x greater than 0, the inverse is square root of x. And if you have fx is equals to x squared or x less than equals to 0, the inverse is minus of square root. Now, if you have something like this, fx, in general, if you take, you will have, this is nothing but y is equals to x squared function, right? If you take something like this, y minus y naught is equals to x minus x naught squared. You can do two things here. The major branches will be x greater than equals to x naught and x less than equals to x. Same as this one, right? Here your vertex was 0, 0. Here your vertex is x naught, y naught. That's why we're taking it greater than x naught or less than x. This is the vertex. Point is x naught, y naught. So we're taking two branches of it. Either this one, only this branch, or the decreasing branch. Only choosing this one. This branch will be for x greater than x naught, it's this. And for x less than x naught, it will be this. Your domain then will be this. And then this one, it's this. This will be, if you have to find the inverse, it's going to be y naught, y minus y naught, square root of it, and then you will add x naught to it. So this will be your f inverse of x. You can say y. You do know that we can replace the y with fx. Right? This is just fx. So this is it. And then if you have x less than equals to x naught and the same function here, this is going to be x naught minus square root of y minus y naught. What happens is, if you're taking it for x greater than x naught, then you take the positive square root. If you're taking it x less than x naught, you take the negative square root. Wait, have here, you will take the square root of it. If you take positive square root and x naught on that side, that's fine. And then if you take the negative square root, yeah, it's fine. Is this okay with everyone? the inverse thing of quadratic functions. So if you just know these things and you've been asked to find the inverse of this. So let's first write it in that form, y minus y naught equals x minus x naught squared. If you write it, this will be y is equals to, this is 6x. That means 2 times 3x. That means it's x squared minus 2 times 3x plus, you can add 3 square here, plus 1. Now this means we are just completing the square here, that's it. If you want to go from this form, if you want to go to this form, y minus y naught equals x minus x naught squared, that means you'll have to complete the square here, right? That's what we're doing. So this will be x minus 3 squared plus 1. And this will be y. So this is nothing but y minus 1 equals x minus 3 squared. Now, if you know this thing, if you know this basic concept, you can just directly say from here that the inverse, f inverse of x should be square root of
Y minus 1
x.
plus 3. X minus 1 plus 3.
Let's take it the function of y. If you take the function of y, you have y
Then
plus 1 second. You'll have
Y minus 1
y
the square
minus
root of
1
this,
plus 3.
the square root, and then plus
3.
And because we prefer functions in terms of x, we prefer the variable to be x, so it's this. We've taken the positive square root here. Why have we taken the positive square root?
Ma'am, because the range for f of x is 1 to infinity. So that would become the domain of inverse.
Or in other words, you can just say this has to be greater than 3, right? This thing is greater than 3. Now, if you take the negative square root, this thing is no more greater than 3, it becomes less than 3, right? If you have this thing, when you take the square root, we basically have plus minus here. Or when you do this thing, let's not call it f inverse yet, you will have x equals to this. But our problem is that your x can only be greater. This is it, right? We've just rearranged things. Square has gone to that side. It will be plus minus square root of y minus 1 plus 3. We've kept both plus and minus. But the domain is that domain means what values can x take. X can take values from where only? From 3 to infinity. But x plus, if you add this to 3, if I'll take 3 plus square root of y minus 1. This is fine because this is a positive thing. Square root of any number is positive. Positive when added to 3 gives a number greater than 3. That means your x is greater than 3. Now this remains greater than equals to 3, which is consistent with this information that your x has to come from 3 to infinity. But if you take 3 minus square root of y minus 1, this becomes inconsistent because this means if you take x equals to this is less than 3, which is not where x is supposed
Ma'am, your voice is breaking.
to be. That. But
Yes,
if you
ma'am.
look at this was for conceptual things. If you want a quick trick for it, it will be your range should be domain for f inverse and domain should be range. So if you'll apply that thing, if you're trying to find f inverse of x, you have plus minus here, and if you have to find f inverse of x and you're doing plus minus, you're not sure what to take, plus or minus. If you will do this thing, it goes the same thing. It becomes same because is this clear to everyone?
Yes,
Or should I explain the domain range way too? That's why I said if you remember this, this is like a short trick that you can have. If you have this thing, if the function is this, and it's given for x greater than x naught, that means if the domain of the function is greater than the vertex, this is the x coordinate of vertex, right? If your domain is greater than the x coordinate of your vertex, then this is the inverse. Then your square root has to be positive. Otherwise, you take the square root to be negative. Because it's given to be for x, this is your vertex, and it's given to be for the numbers greater than your vertex. This is the x coordinate of vertex, right?
Okay, ma'am. Ma'am, like, can you
So you should
repeat
take
that?
this.
Like, why you are taking positive square root?
Okay, if you
Uh,
have this thing, you will get x equals to, we'll get this expression if we'll solve it, right?
yes,
If we'll
ma'am.
solve it properly, we'll take square root on both sides. I should get x, and I should get plus minus square root of y minus 1
Yes,
plus
ma'am.
3, right?
Yes,
Now, if this is, there are two possibilities. Either you'll take, or maybe you can take both. So let's see. Either you can take positive, or you can take negative, or you can take both. Now, if I'll do 3 plus square root of some number, now square root of some number is positive, right?
yes, ma'am.
Now, if I'll add something positive to 3, I'll get something greater than 3, right?
Yes, ma'am.
That means this says your x is greater than 3, which is consistent with this detail, right? That your x is greater than 3. But if you will have this thing, 3 minus square root of y minus 1, basically 3 minus square root of something. That means this is, you're subtracting something positive from 3. So you're going to get something less than 3, right? If you lose
Okay,
this side,
okay,
if you
okay,
do negatives. If you do 3 minus square root of this, you get something less than 3. And x cannot be something less than 3. It's not in the domain. That's why this inconsistency comes in. That's why you should be taking positive square root instead of negative one. This was for the conceptual detail. And if you want to just quickly go through things, if you have a vertex here, if this is, if the x coordinate of this vertex is x naught, if this is x naught comma y naught, and you have to find the inverse of this branch. So for this branch, you have to take square root, right? So take positive square root. For the other branch, take negative square root. That's,
okay, okay, ma'am.
don't have to remember any these things. Can we move to the next question? Is this one done? So it should be, and we are both in options by the way. This is the correct one here because it's inverse of f, where the domain of f is minus sorry 3 to infinity to whatever it is. And this could be correct if this is also the inverse of f. But then the domain of f should be from minus infinity to 3, right? This.
Yes, ma'am.
And this is like these two are just absolutely incorrect. Can we move to the next question if this one is done?
Yes, ma'am.
Does anyone have any doubt in the previous question?
No.
Okay, then do this one. Actually, there's nothing there in this question. We should just We shouldn't waste time on this one. So this is just, you have to compose this function 3 times. So this will be f of, let's first find f of fx. This is, you have to you have to put fx in place of x, right? And your fx is this. So you will have x in place of x, you will put x by square root of 1 plus x square. Or should I write the entire thing like this? First, fx by square root of 1 plus f squared, and this will be x by square root of 1 plus x squared divided by 1 plus x by square root of 1 plus x squared, and this entire thing squared. So this is x 1 plus x squared, and this is 1 plus x squared by 1 plus x squared square. So the numerator remains same, and this becomes 1 plus 2x squared square root by 1 plus x squared in square root, and this was x by 1 plus x squared. So this one and this one gets cancelled, and you're left with x by 1 plus 2x squared. Calculation, everything fine with everyone. This, and then, so this is when you compose them 2 times. And if you compose it one more time, that means if you substitute this thing in fx, so f of x by square root of 1 plus 2x squared then becomes, just put in place of this, you should be substituting this thing, right? So it will be x by square root of 1 plus 2x squared divided by 1 plus x by square root of 1 plus 2x squared, and this entire thing squared. We've substituted this in place of x. So this becomes, the numerator remains same. So this again will become 1 plus x squared, 1 plus 2x squared. This entire thing is in square root. This will be this. And the numerator is the same, x 1 plus 2x squared in square root. And this becomes 1 plus 2x squared plus x squared, so it's 3x squared by 1 plus 2x squared under the root. So you can separate the root here and here. So again, these two get cancelled, and you're left with x by square root of 1 plus 3x squared. These were just calculations, and I hope this is one of the options. The options are this. This is what we got, right?
Yes, ma'am.
Yes, ma'am.
Okay. So the next question.
Yes, ma'am.
The next. You guys can try this one.
Option A would be an answer.
Okay, let's see. A. The function is x. Let's first discuss this thing. You have x and 5 to the power. Now, this is an exponential function, and this is just your straight line curves, a linear function, right? And a linear function is it's this. If you have something this, an exponential function works like this. And it increases very rapidly. So if you have this is a straight line curve, where exponential once it starts increasing, the changes it, it changes very rapidly, and this one changes very slowly. It's a very consistent change. So the point here is that this one is going very slow and this one increases very rapidly. That's why the next tends to infinity. All the both of them are going to infinity. This is also going to infinity. This is also going to infinity. But this one is going to infinity way rapidly than this one, than the numerator. That's why this entire expression tends to infinity. Now, if you will have fx by x instead, this is also going to infinity. This is also going to infinity as x tends to infinity. But this tends to infinity way more rapidly than the denominator this time. That's why this entire thing gets pulled towards infinity. And this one, sorry, this one I'm
Towards
forgetting.
zero, it should, right?
This one, yeah, this one tends to infinity. This one tends to infinity as well. But if you take, okay, if you have this thing, this is like very little things about limits. If you have 1 by x tending to infinity, or let's
Is
say if
zero.
you have x tending to infinity, that means your 1 by x, this should tend to 0. So if your that if your x will go to infinity, 1 by x will go to 0. That means if x keeps it's the same as if x keeps increasing, this thing will go to 0 like this. 1 by 2, 1 by 3, it keeps decreasing and it eventually will tend towards 0. The limit becomes 0 then. That's one thing. And the other thing is, so if you have 1 by
Limits and
5x, or
sequences, right?
yeah, it's a limit and sequences, but it's a very minor part to check the end term behavior. In limits and sequences, basically you're going to study it for every point. This is just for infinity and minus. So just limits at the end for end term behavior. So if your fx tends to infinity, then your fx tends to infinity, 1 by fx is going to tend to 0. That means if your 5x tends to infinity and it tends more rapidly than x, then your x by 5x follows the lead of this one, because this is increasing more rapidly. So this is what is changing everything here. This will go to 0.
Yes, ma'am.
That's the point I wanted to make. And you will see it when we discuss derivatives and all, because we can't do LHS here. It's not in this week. And we can clearly see that this one L'Hopital's rule is actually based on the change of how rapidly a function changes. So if this one changes slowly, then slower than this one, this is going to be the deciding factor. Similarly, if you have
And we can
the
also say that
functions,
we are dividing a very small number with a very large number. So that's why
yeah, in very
very
layman
close
terms, that's
to
also true. If
this
you
one.
have x by 5x, this means that this number usually stays smaller than this one. And as you move forward, like for x equals to 1, this is just 1 by 5. For x equals to 2, this becomes 2 by 20. So this one is growing very slowly, the numerator, while the denominator is just increasing very rapidly. This is just still 3 and it has reached 125. And by 4, it reaches 625. It's increasing very rapidly. That's why it goes to 0. X by 2x, or if you have something else, x by 2x can't go to 0 because 2x does not increase that rapidly.
Okay, ma'am.
So all in all,
The
this means
numerator, so in the numerator, we have something like x, but instead of x, if we say have 4x, then
4x also it doesn't increase. Exponential function is
no,
a
no,
very
4 to the
rapidly.
power
That's why
x,
it's
4 to the
if
power
you'll
x.
have 4 to the power x, then you can just take 4 by 5 common and then you can have the power x. So if you'll have x tending to infinity, 4 by 5 is We're into limits now. 4 by 5 is a number less than 1.
Yeah,
If-
sorry, sir. Yes.
So if you have a number less than 1, if you have, let's say, y to the power n, and n tends to infinity, and y is a number less than 1 and greater than 0, that means this thing is going to go to 0. What, because if you have a number, let's say you have 0.5, then the square of it becomes 0.25. Then it becomes 0.125. So if you look at the pattern, it's continuously decreasing and ultimately it just goes to 0. That's why this thing will go to 0. So this thing is going to go to 0 as x tends to infinity. And actually, in exponential functions, you must have done this. A to the power x, when x is less than 0, or sorry, when a is less than 1. The graph looks like this, right?
Decreasing
Yes.
function.
Yeah.
Asymptote around
I mean,
x.
decreasing.
And it keeps,
Yes.
as your x tends to infinity, as you move here in this direction, positive x-axis, where fx keeps decreasing. It keeps coming closer to y equals to 0 this way.
But it won't touch
Yeah.
x-axis.
Won't touch, but we just need to find the limit. So the limit is still 0. It's limiting to 0. Limiting means it won't cross 0 and go below 0. That's what it means. And it will stay closer to 0. Is that okay?
Yes, ma'am.
So for this one, this is the answer. And we were doing this thing, right? X by 5x. So if you have x by 5x, as x tends to infinity, this thing tends to 0. Now let's come to the question. You have this tending to 0 as x tends to infinity, this tends to 0, this tends to 0, and 10 tends to 10 because it's a constant function. That means as x tends to plus infinity, your fx tends to just 10. So this one should be correct. Then obviously the second one can't be correct. It can't tend to two things, two numbers. And then at minus infinity, let's see at what happens at minus infinity. You will have minus infinity.
Yes,
So we had x by 5x and x by 3x, I guess. And then we had 10. So your x by 5x, as x tends to minus infinity, this goes to minus infinity. And your 5x, the graph of 5x looks like this, right? So your x, as your x tends to minus infinity, this graph is going close to 0, right? The height is getting close to 0. This is the height. It keeps decreasing as you move towards minus infinity, keeps decreasing, keeps decreasing. That means it's the limit is 0. So this limit is 0. Now if you have, where should I write it? One second. If you have this thing 1 by fx, and if your fx tends to 0, we can't actually say. If your fx tends to 0, we can't say where this thing will go. But if we know that your fx is always positive, then we can predict that this is going to plus infinity. Why this happens? Let's say you have 1 by 0.1, 1 by 0.01, 1 by 0.001, and this, in this sense, we're continuing. So where fx, this is fx, is going to 0, and this entire thing goes to infinity, right? This is nothing but 10. This is nothing but 100. This is nothing but 1000, right? This number. That means it's going to infinity. But if instead you will have 1 by 0. Minus 0.1, then 1 by minus 0.01, then this thing will be minus 10, this thing will be minus 100, then minus 1000. So this entire thing will go to
Minus infinity.
minus infinity, right? So it depends on this function. If this function is positive, then you can for sure say that if fx goes to 0, this entire thing goes to minus infinity. If your fx is less than 0, sorry, plus infinity. If your fx is less than 0, then minus infinity. We have seen the examples here. And this is now, this is fx, 5 to the power x. And 5 to the power x is an always positive function. It never becomes negative. That means if this thing is going to 0, now this is the same as this one. A function which is always greater than 0, 5 to the power x, and it tends to 0. Then 1 by fx will tend to infinity. So 1 by 5x should tend to infinity, right? This thing, 1 by 5x should tend to infinity. X is tending to minus infinity. That means this entire thing will go to
Minus
minus
infinity.
infinity, infinity, or just in minus infinity.
Yes, ma'am. Minus infinity. So
So the limit is minus infinity. The limit for this is minus infinity. The limit for this is also minus infinity, and this is 10. So there's a rule, although I don't think we need this rule here. The rule is if you have something tending to infinity and something else tending to infinity, let's say you have fx plus gx, and fx tends to infinity and gx tends to infinity. If this is this, if fx and gx both tend to infinity, then this is also going to, the entire sum will also tend to infinity. Same way, if the product tends to infinity, if this tends to infinity, this also tends to infinity. That means this entire expression will tend to infinity. If you have one tending to minus infinity, the other tending to plus infinity, then this will tend to minus infinity. If you have both tending to minus infinity, this will tend to. So it's basically just like addition only. You can, if you want to have a hint as how to learn it, it's like
ma'am, but in the
this.
addition case, if
Yeah,
one function is tending to infinity, another is minus infinity, then we can't say anything, right? Uh,
yeah. That case we can't say anything. But
that
in
is
other cases, there,
indeterminate.
yeah,
Okay.
one thing that so this one is for plus case when both are positive. This one is for product case when it's like this minus infinity. Infinity is just minus infinity. Although these are not numbers. So going by the strict conventional rules, this is not some. This is not something true. Something true in the sense minus, because minus infinity is not a number. That's why product is not valid for it. We only define product for real numbers, right? Real numbers, or
Yes.
at least not for minus infinity. So infinity to infinity into infinity is just infinity, and if you have minus infinity times minus infinity in limit, if you get this thing, that means your product of two functions, one is going to minus infinity, the other one is also going to minus infinity. That's what this thing means. Then this will be plus infinity. And same goes for this. If you have two functions, one is going to infinity, other is also going to infinity, then the sum is going to infinity. But if this is going to infinity, the other one is going to minus infinity, and you get this form, infinity minus infinity, then you can't conclude. That's not conclusive. You can't say anything from there. So this is going to minus infinity. This is going to minus infinity. And if you're both going to minus infinity, that also works. So if you're minus infinity, then this entire thing will go to minus infinity. And minus infinity with a number is just, this number is just too small for minus infinity. So you can just ignore this number. This entire expression, that means, will go to minus infinity. That means as your x tends to minus infinity, your function also tends to minus infinity. Which is not in the option, so both the options are incorrect. Can we move to the next question, if this one is clear?
Yes, ma'am.
This is the next question. So the first option is, just 1 second. So the first option is range of a function is a subset of codomain. So your functions, for a quick recap, this is a function. It's defined on a domain, and this is the codomain. And every value that you get using this function, the collection, basically the collection of all the fx's for x belonging to the domain. This set is called the range, which is a subset of codomain. This is your domain, this is your codomain, and somewhere in your codomain you have range, and range can be equal to codomain at not obviously outside codomain. So first option is correct. It is a subset of codomain. Second one is function is bijective. This is just definitions. Let's come to the other two options. Range of an odd degree polynomial and this other one. So let's discuss the C one first. Range of odd degree polynomials, right? So let's say a a naught plus a1x and so on a n x to the power n. So how does the n term behavior gets determined for a polynomial?
Leading
If that is odd, then one
Yeah, by the
like
leading coefficient, right? Odd even is also there, but for now it gets determined by the leading coefficient. So an is going to determine everything, and your n is given to be an odd number. So if this is an odd number, that means this is the deciding term, right? This decides everything, and everything else is just useless when it comes to n term behavior. So you just have to analyze and focus on an to the power an x to the power n. And n is given to be odd. So if your x tends to infinity, and this is given to be odd, right? So it's like x or x cube or x to the power 5. They all behave in the same manner, which is if x tends to infinity, x to the power odd is going to tend to infinity, right? And let's say an is positive. Let an be greater than equals to 0, or you can't take it to be 0, so just an greater than 0. And this is odd power, right? So this is positive. X is also something positive because it's tending to minus infinity. That means it's eventually positive. Eventually means even if you start x from -2, -1, 0, 1, 2, 3, it eventually will be positive till infinity. From here, it becomes positive. There'll be a number from where it will start becoming positive, and it will remain positive afterwards. So this entire thing is positive. This is also positive, and it keeps increasing, right? That means this will go to infinity. Like for example, you can take an or 3x cube you can take. 3 is positive. X to the power 5 goes to infinity as x tends to infinity. That's why this entire thing will go to infinity. And if you take 3x to the power 5 as x tends to minus infinity, now 3 is positive, that's fine. But x to the power 5 as x goes to minus infinity is this. If
minus
you have 1, yeah. Do I need to just write some terms of this sequence so that you can see that this thing is always negative and it keeps increasing. So it keeps increasing like this, -3, then -7. This is just rough, rough thing that I'm putting here. That's not the actual values you'll get from here. -7, -20, keeps going on like this. So it goes to minus infinity. A negative sequence which keeps decreasing on the negative side. So this is minus infinity. Now, if you have -3x to the power 5, if instead your coefficient was negative, then this will go to, as x tends to infinity, this entire thing goes to plus infinity, and this negative makes it minus infinity. So this will go to minus infinity, and if you had -3x to the power 5 as x tends to minus infinity, so -3 is negative and x to the power 5 tends to minus infinity. That means this entire thing will go to -3, minus infinity. This will go to minus infinity.
and that will
Right?
go to plus infinity.
Yeah. go to plus infinity. Now, if you have this is given to be odd. That's what happens when you have odd numbers. But if you have even, in case of even, what happens is if you have positive here, 3x to the power 5, as x tends to infinity or minus infinity, does not matter. Even we have to take, right? So if this will be 3x to the power 6, this will go to infinity. When x tends to infinity or when x tends to minus infinity, in both cases, this is going to infinity. Right? So because you have an odd thing here, the point here is that if you have a function, a polynomial, and the leading term is this, an is, if you take an positive, like in this one, when your x tends to infinity, your function, this leading term tends to infinity. That means your polynomial term tends to infinity. Here, it increases here on this side, on plus infinity side. And on the negative infinity side, when you have x tending to minus infinity, this tends to minus infinity. That means it decreases here. When x tends to minus infinity, y also decreases. Y means the function's value. So this will be this. What does this mean? And your polynomial is basically, it covers everything from here to there. On one on one end, it's going to this side. On the other, it's going to this side. That means basically it's covering the entire range. Can you see how it's covering the entire range? It's something like this. Because on one side it's tending to plus infinity, on the other side it's tending to minus infinity. That means the polynomial covers the entire range. On the other hand, if you have an less than 0, then as x tends to infinity, your leading term tends to minus infinity, so your polynomial will tend to minus infinity. And as x tends to minus infinity, your polynomial will tend to plus infinity. And every value, because your polynomials are continuous, so every value in between is covered. Which means everything, this is plus infinity side of your codomain. This is minus infinity side of your codomain. And everything is covered, right? When will everything not be covered? When you have a polynomial like this. Now, if you have something like this part of the codomain is not covered in the range, right? This one. Everything below the vertex is not covered. Here. From here to here. This part stays uncovered. Not in the range. Because in both cases, whether an is negative or positive, your polynomial covers everything. From positive y to negative y, everything is getting covered. That means your range should be R, right? Because basically every number on real line here, every number here gets covered. Every number, for every number on y-axis, you have a number on x-axis, such that the image of that number is this number. That's why everything is in the range, right? Is this clear?
Yes, ma'am.
And then we have 1800 to the power minus x. Because 1800 has nothing to do with, it is of no importance here. So instead of 1800, we can just take a to the power minus x. Now it looks like this, a to the power minus x. Your a to the power x, the graph of a to the power x, where your a is greater than 0, because your a is greater than 0, right? Because a is 1800, which is obviously greater than 0. So it's greater than 0. And for a to the power ax, where a is greater than 0, what does the graph look like? It looks like this. And we've already discussed this thing. If you have f of x and you are doing f of, okay, if if your f of x is a to the power x, then a to the power minus x is basically f of minus x, right?
Yes, ma'am.
So minus x, when, what happens when you do minus x? We discuss this. Your x coordinate remains as it is, and y coordinate becomes negative.
The reflection
Or
along
eh,
y-axis.
when you do y is equals to fx, and y is equals to minus f of minus x. This basically means it's the if your x is if you have to look for a trick to learn this, if your y is negative, then it's a reflection about x-axis. If your x is negative, there's a negative in front of x, then it's reflected about y-axis.
Yes, ma'am.
So reflected about y-axis means this. So this thing
Can
becomes
you
this.
repeat again?
Ma'am, we can also do
Okay.
this by checking some value like
Yeah, you
0,
can
1
do
we
that.
can take.
But this is like a short thing that it's true. When you do values, you're not dealing with complicated things. So you can absolutely do it by plugging in values. But sometimes plugging in values is not sufficient. It looks something else and it turns out to be something else later. That's not the case in your course. In your course, almost every question is just very straightforward.
If you can repeat that.
Yeah, I'll repeat this part. This one, right? Which particular part do you want me to repeat?
Yeah,
If you
this.
have, if you have y, let's say you have, we discussed this, right? If you have y is equals to fx, if this is your y is equals to fx curve, and if you put a negative sign in front of y, that means now you have minus y is equals to fx. Or you can write it as y is equals to minus fx. This means you put a negative sign in front of y, right? That means your curve gets y is equals to fx. So if you have to plot y is equals to minus fx, it's the reflection of this curve about, because your y has become negative, so take reflection about x-axis. This is the x-axis. Take the reflection about x-axis. So it's like this. In simple words, it just means you keep the x coordinate as is and change the sign of the y coordinate. So if this point is 2, 3, then the x coordinate remains same and the y coordinate sign changes. It becomes negative. That's it. Is that okay? This is for
Yes.
y. If this is y is equals to fx, this becomes y is equals to minus fx. But if you reflect this same thing, let's say you have this, and if you do, instead of plotting y is equals to minus fx, let's say I want to plot y is equals to f minus x this time. Now what I've done is I've put a negative sign in front of x this time. That means I'll have to reflect it about y-axis. So now it becomes this. Consider this a mirror, and if it gets reflected here, it'll look like this, right? That means if this point is 2, 3, then the y coordinate remains same for this one, and x coordinate changes to minus 2. Is that okay?
Yes, ma'am.
So this is minus of fx is reflection about x-axis. F of minus x is reflection about y-axis. And when you have f inverse x, it's the reflection about y is equals to x line. Now you know the graph of a to the power x, or in simple words, let's not confuse or get confused with symbols. Let's take 1800. If you have 1800, this is the graph of 1800 to the power x. So we know the graph of 1800 to the power x. If you have to plot the graph of 1800 to the power minus x, because that's in the question, right? 1800 to the power minus x. So it should be reflection about, you have taken negative in front of x, so reflected about y-axis. Now this is y-axis. This means this entire thing, treat this as a mirror. This becomes this and this. Now your 1800 to the power minus x is this curve. This is 1800 to the power minus x. And the other one is 1800 to the power plus x. This one. This is a decreasing function. 1800 to the power minus x is a decreasing function. And the option says it should be a decrease. That means it's correct, right? Is this clear to everyone? Or if you don't want to get involved in graphs, if you want to do it strictly using algebra, then what you can do is the function is 1800. Just 1 second. Just using algebra, it's 1800 to the power minus x. So you will have 1 by 1800. Then I'm only plugging in the natural numbers. So I'm plugging x equals to 1, then x equals to 2, then x equals to 3. But it involves other things too. There are numbers between 1 and 2 which I've not taken. 3. Then it's 1 by 1800 to the power 4. And now if you look at this thing, your 1800 to the power 1, 1800 to the power 2, that means this denominator keeps increasing. This thing keeps increasing, and the numerator is just constant, 1. So if
Yes,
your
ma'am.
denominator keeps increasing, your number keeps becoming smaller. That means this is going to go to 0.
But ma'am, before checking by this method, we need to make sure that it is a one function, right? Otherwise, we would have get some. We would have get like we can get one value for two x.
Doesn't have to be, if you have to check if that doesn't have to be a 1 function. You can have a function like this, and it can eventually go to 0, right? Let's say I have this function, and then it starts going to 0. Now the limit of this, it still goes to 0, right? As x tends to infinity, this function fx tends to 0, right?
Yes,
This
ma'am.
is clearly not a 1 function. It
Ma'am,
has nothing to do with 1 functions. Yes.
okay. I'm saying that for this question, I mean, particularly for this question, we need to make sure that it is one function, right?
For, for the fourth, why would
Uh,
we need it to be a 1 function?
because by definition for a one function, if f of like if x1 is less than x2, then f of x1 will be greater than f of x2.
No, they're not saying. Firstly, okay, if you're saying if x1 is for some value x1 less than x2, if fx1 becomes equal to fx2, that's your point, right?
No, I'm
That's
saying that
fine.
yes, I'm saying
That's
that f of x1 is greater than f of x2 for that to be a decreasing function.
No, it doesn't have to be. It can be equal to. If for 2 points, okay, they don't say it's strictly increasing. 1 point is this, but if it is a strictly decreasing function, then yes, you'll have to make sure that it is a 1 function,
Okay, okay, ma'am.
because that only allows strictly less than this or strictly greater than. It doesn't allow equal to there, right? So
Yes,
but it doesn't mention strictly,
okay.
so that shouldn't be a problem. Is this question clear to everyone? Can we move to the next one? This is the
Yes, ma'am.
question. Okay. Next one is this one. Give this one a try. Or actually, let's do it here. Not left with much time. So this is the question. It says the sum of all real numbers k for which x minus 2 is a factor of px. So you have to find the sum of all k's real number case for which this is a factor. So if x minus 2 is a factor of, let's say, px, this means p of 2 should
Equal
be
to
0,
0.
right?
Yes.
Now this would mean if I substitute what is p of 2, it's k 2 cube 8 plus 2 k square 4 and x square plus k cube 8. So this is basically 8x square plus, oh, why do we have a x? We should have k here, right? This will be 8k square, then 8k, and then 8. This is your P2, which is given to be 0, because x minus 2 is a factor. And then you will have k square plus k plus 1. And what are going to be the roots of this? So it is, if you use the quadratic formula, you'll have minus 1 plus minus square root of b square, which is 1 minus 4ac. Why are we getting negative? Have you made a mistake somewhere?
Ma'am, you have missed a k in the
Yeah.
expression.
We have, okay,
8k.
this one is
That's
8,
not this.
this one was k cube.
K cube. Yeah.
Now everything changes. Yeah. It becomes k cube plus 8k square plus, okay, this is 0, given to be 0. One is clearly visible, it's k equals to 0. So one is k equals to 0, and the other is k square plus 8k plus 8 equals 0. The roots will be of this quadratic one and this one, linear one. So they are k equals to 0 and k equals to minus 8 plus minus b square, which is 64 minus 8 times 4 is 32 by 2. This is minus 8 plus minus square root of 32, and it is basically 16 times 2. So it's 4 root 2. 4, this as minus 4 minus 4 minus 2. By the way, we didn't need to simplify it this much because we ultimately have to find the sum of k's, right? All possible k's. The sum is going to be equal to 0 plus this thing, minus 4 plus 2 root 2 and minus 4 minus 2 root 2. So this is minus 8 and these two get cancelled. The sum is minus 8. And then next up, finally, I think we have this question.
Hello, hello.
We have a doubt. Yes.
Yeah, but we can't directly minus b by a sum of roots.
Yeah, you can do that too. But the sum, yeah, the sum for the sum of roots you have, if you use the sum of roots thing, this is given to you and it's given that x minus 2 is a factor. So see, you have to find the sum of roots when x minus 2 is a factor. So x minus 2 has to be a factor. For this, you have to see this. And you have to find the sum of every root of this. So this is what you have to consider. And the sum of roots for a cubic equation is, you can also use that. Alternatively, sum of roots is like alpha, beta. Let me just write sum of roots. Sum of roots of cubic polynomial is minus b by a, and minus b by a here is this is, so if this is a x cube, if you compare it to this form, ax cube plus bx square plus cx plus d, you can compare it to this. D is 0 in this, so your b is minus 8 and a is 1. So from here you have minus 8 by 1. That's also fine. This is actually a quicker route to find solution. Can we move to this one? This one. So you have this, and a function is given to you, and you just have to find the inverse. So how do we find the inverse? If the function is given fx equals 2x minus 1, x plus 3, you write it equals to y, consider fx equals y, replace fx with y, and then write x in terms of y. Now you have y in terms of x, you need x in terms of y. So this becomes 2x minus 1, yx plus 3y. Simplifying this, this is the same as 2x minus yx equals 3y plus 1. This means you can take x common from here, and 2 minus y equals 3y plus 1. So you have to write x in terms of y. X is 3y plus 1 by 2 minus y. And this is the same as f inverse of y. So your f inverse of x, if this is f inverse of y, that means f inverse of x becomes 3x plus 1 minus x. The inverse is 3x plus 1 and 2 minus x. That means your a is 3, b is 1 on comparing the coefficients, and c is 2. And you have to find a plus b plus c. That should be equal to this. Okay.
Yes, ma'am.
Yes, ma'am.
And okay, there's one more question. You have to find which, you have to tell which one of these are bijective functions. Let's see for,
B and C.
okay. This one can clearly not be correct because it's a square function. Square of minus 1 and square of 1, both
Only
is the
C.
same as 1. So this is incorrect. Then coming to n cube, okay, this is not a bijective function because the domain, the problem is domain. Your x cube is generally a bijective, not generally. X cube is a bijective function if you take it on the entire real line. But it's not bijective here because you have changed the domain. This is the problem. This is why is B not bijective, because it's n cube. Now if I'll take, let's take 10 belonging to integers, which is the codomain. And in domain, so there does not, this is the symbol for there, no x belonging to z such that x cube is equals to 10. We don't have any real number, any natural number or any integer. We need integers, right? So there, because your domain is integers, so you need an integer. and there does not exist any integer such that the cube of an integer is 10. No integers cube is 10, right? If you
Okay.
solve this, you will get cube root of 10. Cube root of 10 is not a real number. Is not an integer. It's a real number, but it's not an integer. Actually, cube root of 10 is three numbers. Three numbers in complex numbers, complex plane, you will have three numbers that can be square root of 10. And none of them is in the set of integers. Like x square, when you write x square equals to 1, there are two possibilities, right? -1 and 1. Both of them are in integers. But when you write x cube equals to 10, there is no integer for which the cube, in simple words, no integers whose cube is 10. That's it. That's the problem. That's why this is incorrect. If you will change, that's why I emphasize on this point that this function from R to R is a different, now you can see why it's a different function. If you define fx equals to x cube, this is a different function from this one, and this is a 1-1-1-2 function. This is a bijective function.
Okay. But it is 1-to-1, right, ma'am?
Yeah, it's 1-1 and onto both. X
Uh,
cube is 1-1 and onto both.
Ma'am, this one which is given in the question,
Yeah,
it is
this one is
1-to-1, right?
it's 1-1, right?
Okay.
This one fails to be onto, surjective. And then coming to the third one, it's a linear function. Linear functions are always 1-1 and onto, no matter the domain and all. Because it's basically, if you have, in simpler words, firstly you will need to check onto. So why, sorry, 1-1. So why is it 1-1? 1-1 because it's, in simple words, it's a strictly increasing function, right? You'll have values as 6, or you will start from, it's basically this. Your fx equals to, what is it? X plus 5. It looks like this. Now, if you'll only have it for natural number, for integers, let's say this is 0, this is 1, this is 2, so on, and on this side it's -1, -2, and so on, so on. This point is -5. Or wait, this is, let me just draw it properly. You'll have your x-intercept is -5, right? This is it. And if you'll only take it at natural numbers, you'll have -5, -4. Let's say you have -1, 1, 2. So this will be here, then here, then here at x equals to 3. Similarly, on this side, it will be here, here, and here. So the plot will look like this, and you can just remove this entirely. So the graph now for fn equals to n plus 5. Where n belongs to integers, the graph looks like this. And it's clearly a 1-1 and onto function both, right?
Yes, ma'am.
Because it's strictly increasing. That's why it is 1-1. No two numbers have same value. You can see from it. Or if you want to do it the algebra way, you can do this way. N1 plus 5, if is equals to N2 plus 5, this would mean that N1 is equals to N2. The definition of 1-1.
Ma'am, this is the mathematical way, right? Like f of x2 equal to f of x1. Then x1 should be equal to x2. Ma'am, the other way, can we check? Like, if we take first x1 equal to x2, then f of x1 should be equal to f of x2. In that way, can we check
That
that?
should be, no, that's for well-defined function. That's a condition for it to be a function, for a map to be a function. So what you do
Okay, okay.
is, for 1-1 functions, definition of 1-1 is if x1 is equals to, sorry, if fx1 is equals to fx2, then this should imply that x1 is the same as x2. This is for 1-1 functions. And definition of a function is, we also call it to be well defined. Definition for a map to be well defined is when you say x1 equals to x2, should mean that the images are also same.
Okay, ma'am.
It's like this is domain, this is it. If you have x1, x2 as same, if this is x1 and this is x2 too, then the images should not be different. fx1 and fx2 should not be different. Now, if this will happen, then it's not even a function, right? So
Okay, ma'am.
that's for a function, for you to check if
Ma'am,
it's a function or not.
is there any example that like the way you are checking something is a function or not, x1 equal to x2, in that way, can you give an example where that will absolutely be a function, but that will not be one-to-one?
So you want an example of a function, but it's not one-to-one, is it?
Yes, ma'am. By checking this way, like this condition should be
This
satisfied.
one, by
No,
definition.
no, the right side one.
No, this one is for a function. If you're saying that if it's a function, let's take this one. Let's take 3x squared, right? Now this
Yes,
is,
ma'am.
if I'll do x1, let's take x1 equals to x2. Now if two numbers are equal, that means the squares are also equal. Do you know any number for which you have two squares?
Uh, okay,
A number
okay.
which has two squares. That's
Okay,
what it
if
means.
x1 equal to x2, then
Yeah, the squares are also
x,
equal.
yes, yes, okay. Okay, ma'am, got it. And ma'am, what is the like mathematical way to check a function is onto or not?
Mathematical one, mathematical way would be, if you have fx equals to, let's say you have a function, it's defined from R2, let's not even take, let's take domain and codomain. What you do is you take a y from your codomain, any random y, and when you take y, just make sure it's not a particular number. Let's take a random arbitrary number, right? So if you have, even if you have real numbers, just take y. And you try to find if there is a number. Basically, you'll have to try to find the pre-image of it. But it's not always very easy because let's say you have x square plus 2x. No, you don't even have to check for x and all of this. Let's say you have x plus 1. If this is it, if this is your function, then you can put any number y here. And you just need to make sure that one x for it exists. So you can take everything on the other side. This is the x for which the image is going
Okay.
to be y.
Means
So
at
that's the
least
clear.
1x should be there. Is that, ma'am?
Only be one x. Because if you have two x, okay, yeah.
If we have 2x, then
That
that
is,
would
there's a
be,
problem with one.
yes, ma'am.
Nothing,
But
nothing wrong with one.
okay, okay. Okay, this thing was like I was facing problem in finding the onto-ness of a function. So this method is very good.
So it doesn't actually always work. Because what happens is you might have things where you can't use this. There are
Okay.
functions where you can't actually find the value. Let's say you have x cubed. We know that x cubed looks like this. That's why we know that it's an onto function, right?
Yes, ma'am.
Now, if you wouldn't know the graph of it, and then if you'll have something like, or we also know that we can take the cube. But if you have x square, x cube plus x square plus 3, if you have something like this, and then if you do 2, and you'll try to find the root of this, and basically what you're doing is, for any number r here, what you're doing is you're trying to find the root 3 minus r equals 0 for any r, any real number, right? If your codomain is real numbers, then you need to make sure that for this function, if this is your function fx, this function to be onto, you need to make sure that every real number has a free base. That means where this has a root, at least one real, right? Can you really find the root of this?
No, ma'am, no.
So that's why it's not, the definition does not always work. Absolute definition for onto is this, that for every number in the codomain, there should be a number in domain. But it doesn't
Okay.
always work. That's why in the previous one also we did this thing, right? It tends to plus infinity, tends to minus
Excuse me,
infinity, so
ma'am.
everything is covered. Yeah,
The recording
Okay,
of the
ma'am.
session will get. I missed actually initial 1 hour.
it's on YouTube channel.
Please upload the recording of the session.
I don't think there's any, we'd save the recordings anywhere. It's on the YouTube channel.
Okay. Is there any link?
In the
Someone share the
YouTube,
link of the YouTube channel.
Yeah, okay. Okay, thank you.
Okay, so I think we're done with all questions. Are we left with anything? Yeah, one more option is left. It's mod of n. So Fn, the option is Fn equals to mod of n. Firstly, it's not 1, 1, because minus 1's mod and 1's mod is both same, equals to 1. So not 1, 1. And it's not even onto, by the way. Because if you have integers, then no integer has its mod as -1. So it's neither 1, 1 nor onto. Is this fine?
yes, ma'am.
Does anyone have any doubt? We can wrap up this session here.
I had a doubt in graded assignment, so maybe tomorrow we can take that.
Yeah. Okay. Does anyone else have any doubt in what we've discussed so far, or some theory from week 5?
No, I also doubt in G.
Okay.
Hello.
Yeah.
So if I talk about the, let me, for the domain and range, say for a function FOG,
Hmm.
first the ideal approach that the lecture was taught, the ideal approach is to find first inner function, the domain of Gx, the
Yeah.
inner, and then find the range of G, and then find the domain of F, the outer one.
Yeah, that's what we did, right? What did
Yeah.
we do? Okay, if that is the definition I wrote, right? Domain of G intersected with X such that your Gx is in the domain of F.
Yes, yes.
Gx means
Yes.
Gx means the range of G.
Okay. Okay. Yeah.
That's the same thing.
Yeah. Okay.
Anything else that anyone wants to ask? Okay, then. Yeah. Bye.
Okay, ma'am. Thank you so much for the session.
Thank you. Good night.
Thank you, ma'am.